All right, this is example 3 for expected value. So this one's going to look a lot like number 9 in your homework problems out of your bookwork. So just kind of pay attention to what's happening with this example, and hopefully it'll help you with number 9 in your textbooks for the section 7.5 homework. So still looking for expected value, and we are told a card-playing dog offers you the opportunity to join his game. The following are the rules. So you must pay him $2 to join the game. And if you pick a spade from the shuffled pack, you win $9. So you've got to pay $2 regardless. And if you win, you will receive $9. Find the expected value. So let me scroll down here. First, the most important thing, every time you're looking for expected value, you need the probability. So we're looking for, if you will pick a spade from the shuffle pack, you win $9. So I'm looking for the probability you pick a spade. This takes us back to 7.1 notes. To find that probability, I need the total outcome, which is 52. We're dealing with a deck of cards. And to pick a spade, I'm using 13, because if you think back in your notes, there were 13 spades out of the 52 cards. So the probability that you're going to pick a spade is 13 out of 52. That's the first step. But remember, you may not pick a spade. You may pick a diamonds or a club or a heart or something like that. You may not always get that spade that you need. So I need to find the probability that you don't pick a spade. I'm going to say 1 minus your current one. So that 13 over 52 was the probability of picking a spade. And why did I do 1 minus? Well, if you had 1, you're at 100%. So anything left over from this probability is the naught, also known as the complement of the probability. So 1, remember when you looked at the probability, if it was 0 to 1, 1 being it certainly will happen, it will happen. 0 being it will never happen. I'm using my 1 as my total, minus the probability that I will pick a spade, to give me what I will not pick a spade. So 39 out of 52 chances I will not pick a spade. And that kind of makes sense because there's only 13 spades, so you're more likely to not pick a spade than you were to pick a spade. So you've got the probability of winning and the probability of losing here. Because remember, if you pick a spade, you win $9. If you don't, your 39 over 52 probability is your losing probability, your loss. So let's put this to use. Let's set up our little table. So the bet value, you win $9, but remember, you paid $2. So technically, you're only winning $7 because you've already paid the $2. So you technically win $7 if you win at that probability of 13 over 52, because it's 13 spades out of 52, if you win. But what if you don't win? You're still out $2. You still had to pay that $2. And the probability of not picking a spade is 39 over 52. So you're more likely to not pick a spade. If you lose, you still have to pay that $2. You'll notice I put a negative in front of it because you're at a loss. You've paid that $2, you don't get it back. So we put a negative in front to recognize that. The biggest thing there was the $9 and the $2. Yes, you win $9, but you had to pay $2 to join the game. So you technically only win $7. This happens a lot with lottery tickets. You pay $1 for a lottery ticket, you win $5, but you technically only earned $4 because you paid the dollar towards it. Okay, so to find the expected value of this, I'm using the $7 if I win, times the probability if I win, plus the negative 2, because I lost $2, if I don't pick that spade. So when I compute all of this together, I end up with 25 cents. So your expected value is 25 cents off of this game. So number 9 in your book, I'm going to work it out as well and make a little video because it kind of talks about different tickets. And it's a little bit more advanced than this one, so I'll make a video on that one as well. So stay tuned.